Hello everyone. So today let's solve the problem Arpa's letter mark tree and Mehrdad's Dokhtar-kosh paths. Right. So this was asked in the code forces around 283 division 1. Right. So this is rated 2900. Oh, so what the heck is this figure, man? So this uh, looks like a baby in the horror movie, man. What the heck? So this is fine. Let's do one thing. Let's not see this picture actually. Let's do one thing. Let's solve the problem, right? So what the question states here, yeah, you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. Also, let's not see this pic as well, right? So I'll just come here. 1 second, just give me a second here. Yep. So let's see what the question states here. We have been given a rooted tree, nothing but initially it will be rooted to 1, right? This will be nothing but root. This is nothing but the root, r equals 1, whatever I have written. With the lowercase letters, with the lowercase letter on each edge. Letters only from A to V. From A to V, right? Again, given a rooted tree, root equals initially 1 with a lowercase letter on each edge, letters only A to V. A string is Dokhtar-kosh. So they have strictly mentioned here. A string is Dokhtar-kosh, this one. Dokhtar-kosh, if its letters can be permuted to form a palindrome. If its letters can be permuted to form a palindrome, right? So this part is very important, to form a palindrome, right? So this is fine, I believe. Yep. So we have been given a rooted tree where root equals 1 initially with a lowercase letter on the on each edge. Letters we have to consider only from A to V, right? A string is Dokhtar-kosh if its letters can be permuted to form a palindrome, right? For every vertex V, we have to find the maximum length. What we need to find here, for every vertex V, we have to find the maximum length, right? Just remember this one. For every vertex V, we have to find the maximum length, nothing but the number of edges of any simple path entirely inside the V subtree, of any path entirely inside the V subtree whose edge letter string is, whose edge letter string is, so this one, sorry, 1 second, whose edge letter string is Dokhtar-kosh, right? Dokhtar-kosh. This is fine, I believe. Yep, this is it for the question. Let me read the question out loud. Just listen to this carefully. So we have been given a rooted tree where r equals 1 with the with the lowercase letter on each edge, letter only from A to V, right? A string is Dokhtar-kosh if its letter can be permuted to form a palindrome, this part, right? So one more thing, at most one letter has the odd count here. Just remember this one. At most one letter has the odd count. So for every vertex V, what we need to do, we have to find the maximum length, nothing but the number of edges of any simple path entirely inside V's subtree, whose edge letter string is Dokhtar-kosh, right? So that's what we need to find. We need to find the maximum length of any simple path entirely inside the V subtree, right? Whose edge letter string is Dokhtar-kosh, right? So this is fine. Let me delete this one entirely. Now, let me come to the input output part. So this one, see, they have given the what do we call chain basically. 1 to S, we have 4 uh, totally. So 1, 2, 3, this one, 1 followed by 2, this one 2A, 3S, and finally this one 4. We have been given 4. This is a chain of 4 basically, 1S, 2A, 3S, 4, right? So the output that we need to get here is 3110. 3110, right? So this is the input output. Same goes with the input 2 as well. You can just go with a similar way. If you can go in the similar way, right? Let's do one thing. As we're completely familiar with the question and the this one input output part, let's discuss the this one approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So let's consider the same first example that they have given in the question basically, right? 4, 1S, 2A, 3S. This forms a chain, right? So 1 followed by this one S, this one 2, uh yeah, sorry, one second. 2a, 3s, finally 4, right? So the output that we need to get here is 3110. So we will be making use of the DSU, disjoint set union on the tree, basically bit mask parity optimization. So we'll be going with a parity optimization as well, right? So let's see what we'll be doing. Let's go with a step-by-step explanation. Let's see the key idea first. What we will do, we will represent the parity of the letter counts along the route, right? Along the route to the node with a 22-bit bus, 22-bit mask st of u. This is fine. Will represent the parity of letter. This one counts along the route, this one route to node with a 22-bit mask st of u. For any two nodes, that is nothing but x comma y. This one, the mask of the path x minus y is equivalent to the st of x xor st of y, right? So the path is called the Dokhtar-kosh if this XOR has less than or equal to 1 bit set, less than or equal to 1 bit set, right? Less than or equal to 1 bit set. For each subtree, we need to find two nodes inside it, right? So for each subtree, what we need to do, we need to find the two nodes inside it that maximize the distance subject to the st of x, again, square root, sorry, x or st of y, that is having less than or equal to 1 bit set. So this condition is very important, right? So it's called Dokhtar-kosh if this XOR has less than or equal to 1 bit, right? 1 bit set. So that is the reason we are continuing with the third one. For each subtree, we need to find the two nodes, right? For each subtree, we need to find the two nodes inside it that maximize the distance subject to the st of x, x or st of y having less than or equal to 1 bit set, right? So DSU on the tree, nothing but disjoint set union on the tree, keeps the map from st, nothing but maximum depth seen for that st, allow squaring best partner depths fast, right? So this is fine. So let's consider the example. Let's try to implement the same thing in the form of code. First, depths, this one, and mask, let's consider. So initially, st of 1 equals 0, d is also 0, right? St of 2 is bit of s, d distance will be 1. And st of 3 equals bit of s, xor bit of a, d equals to 2, distance 2. And st of 4 equals bit of a, d equals to 3. So this is what we will be going with basically in simple terms, right? For node 1 subtree, the pair 1 comma 4. So we have actually this one 1s, 2a, 3s. So this one is 4, right? So one second. For node 1 subtree, the pair, this one we have one subtree, the pair 1 comma 4 gives st of 1 xor st of 4. You can just check this one. That is equivalent to the bit a, nothing but the single bit, right? So this is valid. Distance will be equivalent to the depth 4 plus depth 1. This one minus 2 into depth, nothing but the LCA, that is equivalent to the 3 edges to root answer. So here in this case, we have got the output 3, right? For the node 1 subtree, the pair 1 comma 4 gives this one, st of 1 xor st of 4, right? So bit a to the single bit. So this is valid. Distance is equivalent to the depth 4 plus depth 1 minus 2 into depth of this one, LCA. That is equivalent to the tree edges, right? Root answer is 3 here. Root answer is 3. For the node 2 subtree, first we got 3. For the node 2 subtree, the best valid single edge paths are this one, 2, 3, as well as the 3, 4. You can just build the this one tree kind of structure and you can just see, right? Or the graph kind of structure and just see. Paths are 2, 3 and 3, 4, but only single edge ones with a letter that produce the palindrome, right? So the best length that is found is for the answer 1. So this one is, yeah, found as 1, right? For the answer 2, sorry, answer 1 is 1. Answer 2 of 1 is 1. Answer 3 of 1 is also 1. And leaf 4 has no edges at all. Leaf 4 has no edges at all. When there are no edges, we'll consider 0 basically, right? Leaf 4 has no edges, so we'll consider 0 here, right? First we got 3, then answer of 1, answer of 2 equals 1. Similarly, for the answer 3 of 3, answer of 3 equals 1, and finally leaf 4 has no edges, so we'll be considering 0 for this, right? So the output that we got here is 3110, 3110, right? So the final answer that we got here is 3110, which is equivalent to the output that they have shown for the example 1 within the question, right? Simple, right? So now, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So what would be the time complexity here? The time complexity would lead to big of n, right? So why it is big of n here? See, uh, we actual time complexity is big of n into 22 plus n, which is sorry, 1 second, just give me a second here. Yeah, it's big of n into 22 plus n, which is almost equivalent to the big of n into 22. We can just represent this one as big of n. So n into 22 plus n, which is almost equivalent to the big of n into 22, and we can just represent this one by big of n, where each node's mask checks 22 bits, right? Also, we are performing DSU on the tree. So DSU on the tree ensures each node is added or visited a limited number of times. So the space complexity would lead to big of n plus 2. This one, the time complexity would remain big of n. The space complexity would lead to big of n plus 2 to the power of 22, because we'll be going with the arrays for the tree, which will be big of n plus we'll be considering the map of size 1 left shift 22. So basically it would be n plus 2 to the power of 22, basically space complexity, right? So this is fine, man. Yeah, primarily we got the space complexity because n plus 2 to the power of 22. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n plus 2 to the power of 22 respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So yeah, I'm in the one compiler. So we'll be making use of the different utilities. So let me import here java.util.start. Right. So let's go with a custom fast input and the output man for this one. So I'll just go with a public class main. You can just go with any class name that's related to the that's relevant with the problem basically. Right. This is fine. So let me copy paste this one here. So this is basically this one. What do we call? Fast trader, custom fast trader and the fast writer. So I can just make use of the buffered reader and buffer writer. So I'm just going with the intense optimization for this problem. And also one more thing, I have copy pasted this one. I didn't want it to type. Basically, this is just the initialization part. Let me explain this one very quickly. The initialization part, right? So this is nothing but fast reader and fast writer till line number 57. This is nothing but this is purely related to the input output part. So I don't have to explain. You can go with any template of your choice, right? Or you can just go with the buffer data or the scanner with the this one print writer, right? Or you can just go with the scanner. It's your wish, man. Right. So this is fine. Now, what is this basically? This one second. Right, fast reader and fast writer. We are just calling this one. This is fine. We have made use of the fast reader, custom fast reader, and the fast writer for the fast input and the output. This is fine. So min is nothing but the min helper. This one, which is of the type int, and this one max is nothing but the max helper, which is of the type int. And again, we have made use of the max. Basically, this one. This is also the max helper. So this is abs int. So this is this one. Uh, Basically absolute I wanted to make use of this one absent. Now we are going with the GCD long as well as the LCM long, this part line number 66 and 67. We are going with the GCD as well as the LCM, which is of the type long. That's it, right? So the next one int min of something whatever I have considered here, 10 to the power of 8, right? So this one, this is the sentinel minimum value that is used to reset the map entries, right? So don't get confused. So these are the global arrays, man. This head, NXT2, WT, S size, SZ, sun, S1, DP, depth, so ST, this one ANS result variable and MAP map. So these are the global area, this one variables. Uh, 1 second. What did I do, man? Just give me a second here. One second. Yeah. One second. Yep. So these are the global arrays for the graph sizes, masks, this one, answers and the map. Answers and the map. Right. So this is fine. Next, let's move on with the this is nothing but the main method, right? So we have called main here, and we are just this one. We are just running the solve. Then we are basically flushing the output, right? So I have already called the flush. Basically, we haven't written the this one solve method. Now let's write the this one. What do we call the solve or the main logical method now, right? Some of the helper methods as well as whatever we do for this particular problem. Let's write that. So I'll just go with here static void solve, right? So within the solve method, what we will be doing, let's go with the number of nodes, right? So let's go with the number of nodes. So this one will be int n equals c dot I'll just go with the next int, right? This is fine. The next step would be, let me assign head, the variable head, this one to the new int of size n plus 1, and nxt variable we have considered. So let me assign this one to the new int of n left shift 1. This is fine, I believe. Let me go with a variable 2, new int of n left shift 1. This is also fine. Let me go with wt here. So this is new int of n left shift 1. Right, so this is also fine. Now let's go with the size as well, man. Size sg we have considered, right? So this one, let me assign this one to the new int of size n plus 1. This is fine. Let me go with sun here, new int of again size n plus 1. So this will be dp also variable we have considered. So this one will be new int of n plus 1. This is fine. And st equals same thing, new int of the size n plus 1. Right, so basically what are these? These are the helper arrays. These are the adjacent arrays. Line number 76, these are the adjacent arrays. And these are the line number 77, these are the helper arrays basically, right? So after the helper arrays, let's do one thing. We have to read the edges, right? So let's move on with the iteration part. So this one will be for loop in u equals to 2, mm, j equals to 2. We have considered n, I believe. Yeah, u less than or equal to n. Yep, u plus plus. So within the for loop, the first thing is we have to go with a parent v and the bit mask for the single character char char, right? Also, we have to add the edge to u to v, and we have to add the edge to v to u. These three things we have to do. Let's do this one quickly. So this one will be int v equals c dot next int. This is fine. W equals 1 left shift. So this one will be c dot next int. So this one we don't have to make use of the int here. Next is enough. So we're going with the char, right? So I'll just make use of the caret 0 hyphen a. I hope this works, man. Let's see. Let's see. And now let's add the edge from u to v as well as v to u. So let's do this one quickly. Next of j here. This is equivalent to the head of u. This is fine. Head of u. So this one is equivalent to the j as well as wt of j. This one is equivalent to the w, and finally 2 of j plus plus uh, yep, j plus plus equals v, right? So again, let me copy the same thing and make the necessary changes. So u, right? So this one is fine. Next of j, it remains same. So instead of the u, let me change this one to v. This is fine. Head of u is there. Let's change this one to the head of v, and this is equal to j itself. wt of j, this remains same. We are assigning this one to the w, and to uh, j plus plus, this is equivalent to the, right? So this is fine, man. We are done with this part, right? So I'll just come out of this one entirely. Now let's go with the pre-process sizes, heavy child, depth, and the st, right? Root 1 as well as the parent 0, right? So I'll be going with here uh, init helper method, right? So let me go with the init helper method. Let me write this one in it here. Let's do one thing. Yep. Let me go with the helper method in it. Just give me a second here. So let me come out of this one entirely. Now let me paste this one. So this is the helper method init. So what we are doing within the init, so let me explain this one, right? So here init helper method, whatever I have used here. So within this, we are computing the sizes, heavy child, depth, and the st masks iteratively. Will be making use of the iteration, basically iterative method instead of the recursion, right? So iteratively, as I've said, so we'll be making use of the stack, right? We'll be making use of the stacks, right? So this is fine. Now I did make use of the recursion. Basically, I got the this one TLE, so I went with the this one iterative approach. Uh, I won't lie. So here, this one arrays.fill, whatever I have given, arrays.fill size comma 1 and size of 0 equals 0. Basically, we are initializing the subtree sizes to 1, right? Each node, this one to itself. So DQ, this one, we are just making use of the stack for the iterative DFS, right? So this is fine. Now we have to push the starting frame, right? So we have to push the starting frame. That is the reason I have written stack.push of new, this one, FU0, whatever I have given. This is fine. This we know. We are just going with a standard, this one loop, right? So we are just going with a standard loop here. So first thing here in T, whatever I have written. So here, this one, we are peaking from the top frame. We are peaking the this one top frame, right? And if condition, whatever I have written, t of 2 equivalent to 0, this time, first time, this is nothing but the first time visiting node. Here in this case, we are pushing the children, right? So these things will come to know this same thing. This is fine. Now at the line number eight, this one 98, t of 2 equals 1 I have given, right? So we are just marking, to process the post order on the next run counter. Don't get confused here, right? So else I have given here, else what we are doing, we are just going with the post order processing. We are just computing the subtree sizes and the heavy child, right? So what is this if condition then? This if condition is nothing but the accumulator, right? We are just trying to accumulate and this one accumulate the size and pick the heavy child, right? That's the reason we are writing if not equal to v, we are just going with a size of u plus size of v. Again, we have written one more if condition there, size of son of u. If it is less than size of v, then son of u, we are assigning this that one to the v, basically, right? So this one I'm speaking of. So this is it for the init, right? So now let's make use of it within the main method, or this one. So within the main method, we are just calling the solve here, right? See here, we have just called solve within the main method. So all the main logic we are writing within the solve itself, right? So let's call the this one init within the solve actually. So I'll just give here 0, 1. We are just going with the pre-process sizes, heavy child, depth, and the st, right? So root will be 1 and the parent will be 0. That is the reason I have passed 0 and 1 within the init. Now let's continue. Let me give here answer equals new int of the size n plus 1 here. This is fine. And I'll just go with map equals new int of what shall I give here? New of 1 left shift 22, right? So this one, let me give array here. 1 left shift 22, this is fine. And finally, let me go with arrays dot fill this one map comma min, right? Map. So this is not full stop. So this one has to be comma min. So what is this basically? We are just going with the answer array and map initialized to the min, min I have given, right? So now we will be going with a iterative DSU on the tree, right? So in simple terms, we'll be going with the DFS. So we'll be considering parent 0, node 1, opt 0, right? So we don't have to keep, right? So this one, let me give DFS, sorry, not here. So DFS of this one, what do we call? So let me leave it here. So here we haven't written the DFS helper method yet, right? So let's write the DFS helper method and come back to the solve method, and let's make use of that helper method within the solve method. Just give me a second here. So let me come here. Let me copy paste the this one. What do we call DFS helper method, right? So what we are doing within the DFS helper method, let me explain here what we have done basically, right? So this DFS method basically line number 112. So what we are doing here, we are applying the DSU on the tree main traversal, nothing but the iterative. We are going with the iterative approach, right? So now here, this is the stack frame. So this is the stack frame. So we are considering, or we will be considering parent node opt as well as the state, right? And this one stack dot push, this will be the initial frame. So this is the standard loop. We know we are going with the iterative approach, and this will be the standard loop, right? So this one is fine. So what is if s of 3 equivalent to 0? I have written here. This one is nothing but the pre-processing statement. Don't get considered this one confused here. If s of 3 equals 0, whatever I have written, so this one is nothing but the pre-processing state. And if son of u, this one not equal to 0, stack dot push this one, whatever I have written. So what we are doing here, we are just processing the heavy child with opt equals 1, right? We have to keep its map basically. That is the reason we are processing the heavy child with the opt 1, right? Next, we have moved on with the iteration. This is fine. And finally, v equals top e, this one in the line number 120, whatever I have written. So here what we are doing, we are just pushing the light children. We don't have to keep the light children. So we are pushing the light children here. Now again, let's come to this part. S of 3 equals 1. This is similar to this one. T of 2 equals 1, whatever we have given in the init basically. What is this S of 3 equals 1? We are just marking that the children pushed basically. Children are pushed. Next time we will do the post processing instead, right? So now else, whatever I have written, now this is nothing but the post processing. So after the children are processed, we are just merging the light children and we are computing the answer or the result, right? So this is very important. This is just the iteration part. And if f not equal to v, whatever I have written here, so this one for for each light child, we are going with a query of update. Then we are adding its node to the map, right? So this is important. So the simple two if conditions, whatever we have written, this one I'm speaking of. And the line number 128, what we are doing, we are just propagating the best answer from the child subtree, right? I hope this part is clear. Let's come to the final part now. Line number 130. What we are doing here, map of st of u, this one I have written. So we are just including the current node in the map. Basically, we are storing the max depth for the mask st of u here. The next line, whatever we have considered the result variable, answer of u equals max of answer of u, comma this one, map of st of u minus depth of u, right? So we are just checking the partner with the equal st, that is that we are going with a path parity 0, right? So this is fine, man. The next line, whatever I have written for loop, this one iteration part, we have moved on with the iteration part. I'm speaking of the line number 132. So what we are doing there, we are just checking the partners with 1-bit differentiation, right? 1-bit difference you call, not the differentiation basically, 1-bit difference. Now the final one is if opt equals 0, then we are just going with a clear of f of u, right? So this one we have not written this one clear method yet. So we have made use of here one more thing, we have made use of the update and we have made use of the clear here, right? So we don't know what update does and what clear does basically, right? So we have not yet written those helper methods, update and the clear, right? So let's write those helper methods and we have already made use of it within the this one. What do we call? Uh, we have already made use of it within the DFS this one method. So now let's write this update in the clear method, right? So let me come out of this one entirely. The final one, if opt equals 0, clear of f comma u, whatever I have written, man. So what is this? Basically, what is it? So this is nothing but if this subtree should not be kept, nothing but the light ones should not be kept, right? So then we will clear its contributions from the map. That is the reason we are going with a clear, right? So now let's quickly write the update and clear methods, right? So I'll just give me a second here. So we are making use of the update as well as the clear. Also, one more thing, we have made use of the add method as well here, right? Extra helper method add as well. So we have to write these three methods, right? So we are making use of the update as well as the add and the clear this one helper methods within the DFS, right? So let's go with the this one first, update method. Right, so let me paste this one. So let me explain what we have done within the update method. So now for the node O, nothing but the owner. So whatever I have considered in the parameter for the node O, nothing but the owner, we are just traversing the subtree rooted at U. And we have made use of the DQ, this one stack. This is nothing but the stack for the iterative traversal of the subtree U, right? So don't get confused here. So answer of owner, whatever we have considered this line 143. So this one, we are just matching the use mask with a node in the map with the same this one, what do we call, same mask, right? So just to compute the path length, right? So this is fine. So this one, two for loops, whatever I have written. So this one, so the first for loop, so this has to match with the masks that is differing by 1 bit, right? And finally, we have to push the children to the stack. So the second for loop, right? So that's what we are doing within the this one update method. Now, as we are done with the update method, let's do one thing. Let's move on with the add method. Add and clear methods are left, right? So let's write those methods as well. So let me come here. So I'll just paste this one. So what we are doing within the add method. So we have just written the update method, right? So let's see what we will be doing within the add method. Basically, within the add method, add itself indicates that we are inserting. What we are inserting, basically, we are inserting all the nodes in the subtree U into the global map, right? So map of history of node that is equivalent to the maximum depth here, right? So that's what we'll be doing. This is simple, man. So map, whatever we have considered here, hash map, this one, we are just updating the map with a maximum depth for this particular mask. So these two things you have to remember. And finally, we are removing this one, sorry, pushing the children to the stack, right? So this is it for the update, this one add method. Finally, we are left with only this one clear method, right? Let's see that one also in the action. So let me come here. Yep. So what does the clear method do, right? So I had explained this one earlier as well. So let me explain this one now, finally. So clear method, we have or we are resetting the map entries for all the nodes in the subtree U to the minimum. We had discussed this one earlier as well, right? So this is used when not keeping, right? So when not keeping. So let me come to this part, basically the final two lines, 167 and 168. So what we are doing here, so we are just resetting the map entry for this particular nodes mask here. So this one, line number 167, and line number 168, I have written the for loop, right? So this one, what we are doing, we are just pushing the children. So this is same, right? So this one, we are pushing the children, the same thing, same steps almost for the clear, add as well as the this one update, similar ones. Basically, you can just check, right? You can just pause the video and you can check, right? So this is for the this one clear, and this is for the add, and now this is for the update. This is for the update. This is fine. Now I hope this is clear, man. Let's do one thing now. Yep. Uh, we are left with only one thing. So we have to continue with this one. Now we have written all the helper methods. So let's continue with the solve main method, right? So we have called the solve within the main method. So solve is the uh, main thing where we are writing all the this one implementation or the logical part, right? So now we are left with the, so I have called the DFS function basically. So we have already written the DFS helper method. So we will be going with the iterative DSU on trees, nothing but DFS parent will be 0, node will be 1, and opt will be 0. We don't have to keep here as I've said. So this one will be 0, 1, 0. Right, so this is fine, I believe. The next part is iteration part. So we will be printing the answers, right? So we have to ensure it is non-negative as well. Answer should be non-negative. So let's print the answers. I'll just go with the iteration part here for int I equals 1, I less than or equal to n. So I plus plus, right? So let me go with out dot println. So this one will be max of 0 comma answer of I. This is fine. Plus this one is fine. We're just printing the answers. The final one is we have to go with a new line, right? So I'll just go with out dot write ln, right? Out dot write ln. So this is it for the code. So this is it for the code. We have successfully written the code. So this was huge basically. After typing, I have copy pasted the methods, right? So I usually practice after pasting this one. This would have took a lot of time if I showed you the typing as well, right? So that is the reason I copy pasted this one, right? After this one, all the methods I'm speaking of that I copy pasted, right? So this is fine, man. Yep. Now let's do one thing. Before checking the code with the different inputs or the examples, let me copy paste the signature starter template. Just give me a second here. Yep. I'll just come here. Let me paste this one. Now let me come here. Let's check this one with a different input. So this one, the output that we need to get here is 3110. Right. So let me run this one. We are getting the semicolon where the line number 102. So let me come to line number 102 here. We give semicolon here. So we are left with the two errors basically. Static void DFS. Unnamed classes are preview feature and are disabled by default. Which one it is speaking of? The DFS one in it. So this one static void. So we have made use of this one itself, right? Static void solve static void DFS basically. Right in it. Basically, let's check. Just give me a second here. So let's do one thing here. This is screaming because we have made use of the extra bracket here within the init method. So let me remove this one. This is fine. So let me run this one again. So yeah, now that was the problem basically, bracket, right? So we are getting the output 3110, right? So this we are getting in the single line we have to get, right? So here in the output I have given right ln out dot right ln I believe, right? So just give me a second here. So let's do one thing. What happens if I take ln here? So let me run this one. So we are not getting any output, right? So let me do one thing. Let me include here right ln. Yep, we are getting the output. So let's check. But let me submit this one. If it strictly asks within the same line, then we can change the code, right? So let me go with this input. The output that we need to get here is 41010, right? Let's check the same here. So we are getting the output 41010, but we have to get this one in the same line. Let's try submitting this one. Let's see whether bit passes or whether it is that much strict or no, right? Not. Let's check. Let me hit the submit button. Let me paste the code over here and let me hit the submit button. I hope this works for all the test cases. Let's see. Let's wait for some time. So if this passes some of the test cases initially, then it is not that much strict that we have to type that one in the single line itself. So, yep. not moving to the next case at all. Yeah, this is moving to the next test case, right? So uh, it is not that much strict. We can just go with we can just give it in the single line, or we can just go with the multiple lines as well. It doesn't matter, right? So answer has to be correct basically. Whatever the answer that we get, that has to be quite obviously correct, right? So this is fine, man. So this is huge code actually. Yep. Yeah. Uh, yep. Hmm. Let's wait for some time. This is pure actually disjoint set union on the trees, as well as we made use of the DFS as well, right? That was such. Mm, these usually calculating the sand this one, right? Centroid or the middle of the tree. So usually these kind of problems are extremely large, and these are uh, hard to solve, difficult to solve. I won't lie, these are difficult to solve. Again, I'm telling the time management has to be so good while solving these kind of problems in the contest, right? This is basically the division one question, so which is rated around, yeah, almost 3000, 2900, right? So this is quite obviously the difficult one. Let's wait for some time, man. Test case 26. Let's wait for some time. It's running on this one. Test 35. Let's wait for some time. Still running in test case 58. How many test cases are there? Yep, you can clearly see here. It's showing accepted in the toast, right? So the verdict that we got here is accepted, right? Again, so we have just went with the DSU, disjoint set union on the trace. So along with the this one DFS, right? So we have written so many helper methods. I just wanted this one to be in the structured way. That is the reason I have used many this one. What do we call helper methods, right? So I have explained one by one, crystal clear. I've typed this one. I didn't type every this one, everything, so that it would take a long time, right? So this is, you can just ignore this one. You can just go with the any this one template of your choice for the input output, right? So until here, right? So this is fine. I have just made use of the custom fast reader and the fast writer. So the code starts from here basically. So mainly we are implementing the main thing within the solve method, and we are just calling that one solve method within the main function, right? Within the solve, we are making use of the this one init as well as the DFS, right? So within the DFS, we are making use of update, add as well as the clear helper method. I have explained this one step by step, right? So I hope the solution part is completely clear, man, along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.